Alright, so this is going to be another video on related rates, only this time it's going to be a much more complicated problem. So it says a balloon is at a height of 50 meters and is raising at a constant rate of 5 meters per second. A bicyclist passes beneath it traveling in a straight line at a constant speed of 10 meters per second. How fast is the distance between the bicyclist and the balloon increasing 2 seconds later? Now this is a very difficult problem, so to kind of break this down before we even translate all this English into math language, I want to draw a picture of what's going on here. So I have a balloon here, and it's raising, so I'm going to put a little arrow, so it's increasing its height at 5 meters per second, okay? It is doing that at a height of 50 meters, okay? It's at a height of 50 meters, it's raising at 5 meters per second, so I just drew that right there. A bicyclist passes beneath it, traveling in a straight line at a constant speed of 10 meters per second. So I have a bike right here with the guy on it, and it's going this way at 10 meters per second. Okay, so it's directly beneath it, and then it's going 10 meters per second, so it won't, after that instant, it won't be underneath it directly after that. Okay, how fast is the distance between the bicyclist and the balloon increasing 2 seconds later? So we're basically looking for this distance right here after 2 seconds. Okay, so we're looking for this distance right here after 2 seconds passes. So that means after 2 seconds, this 10 meters per second, this bike would have gone 20 meters. Okay, and then 2 seconds added to this, that means that this balloon would be increasing at a rate of another 10 meters, because 2 times 5 is going to be this 10. So this will be 60 total, and this one's going to be 20. Okay, so it's kind of important. You kind of have to take this 2 seconds later into account for how this thing is moving. Okay, now because we have a right triangle here, we're going to use the Pythagorean theorem to figure out how fast this side is right here. And really, I guess it would be more accurate to do this because it's going to be 2 seconds later. We're looking for this distance right here, not this one. Okay, so we're looking for this. Okay, so first thing I'm going to do is actually write down the Pythagorean theorem. So we have a squared plus b squared equals c squared. Okay, now because we're looking for the rate, or how fast the distance between the bicyclist and the balloon is 2 seconds later, that means I'm going to take the derivative of both sides of this with respect to t. So that means I'll have the following. I'll have d over dt of a squared plus b squared is equal to d over dt of c squared. So the derivative of a squared plus b squared with respect to t, and the derivative of c squared with respect to t. So we're going to do some implicit differentiation here. So this would be 2a times dA over dt. Okay, you should know where this comes from. If not, you're going to want to watch the video on implicit differentiation as a little review for where this dA over dt comes from. Then I'm going to do the same thing with this b squared. So it's going to be plus 2b dB over dt is equal to 2c dc over dt. Okay? Now since there's 2 in every single term here, I'm just going to divide both sides by 2, and that would basically cancel out all these 2's. So just to kind of make the math a little bit easier, we're going to cancel out all those 2's. Okay, now our a, let's just say that in this case, our a is going to be this one right here. So this side right here is our A. This side over here is going to be our B. So in this case, our A would be 60 meters. And our dA over dt is going to be this 5 meters per second. So I'm just going to write 5 meters per second. Okay. The B is this right here, which is going to be 20. So it's just that length, 20 meters. And the dB over dt, it's going in a straight line at 10 meters per second. So I'm going to write 10 meters per second, like that. Okay, is equal to, well, this c right here, we don't actually know this c, but we can figure it out because this is a right triangle. We know that it's 60 squared plus 20 squared is equal to c squared. So this c is basically going to be equal to the following. So the 60 squared plus 20 squared is equal to the c squared. This is going to be 3,600 plus 400. So you get 4,000 is equal to c squared. Take the square root of both sides. You get c is equal to the square root of 4,000. Okay, this simplifies to the following. 20 times the square root of 10. Okay, so now from here, this is going to be our c. So I'm going to write 20 square root of 10 meters times our dc over dt. Well, that's what we're looking for. So we're looking for this dc over dt right here, okay? We're looking for the rate at which this and this are spreading apart as this bicyclist is going this way and the balloon is going this way. So as you can see, that C length right here is increasing as the balloon goes up and the bicyclist goes over to the right. Okay, so from here we're going to do some simplification here. So we're going to have 300 plus 200, and it's going to be meters squared per second. We don't really need to worry about the meters or the units so much on this, but you should have 300 plus 200, so that's going to be 500 meters squared per second is equal to 20 root 10 meters dc over dt. Again, we're looking for that rate of change of this c, this hypotenuse right here. So I'm going to divide both sides by 20 root 10 meters. Okay, and then this will simplify as the following. So these 10s are going to cancel, and then the 50 over 2 is going to be 25. So you end up with 25. So you end up with 25 over the square root of 10 is equal to dc over dt. So then you end up with 25 over root 10, and the meters are going to cancel here, so you have meters per second, which makes sense. Your rate of change should be meters per second because it's how many meters it's changing for every 1 second, is equal to our dc over dt. Now, since this is a real world problem, we're not going to keep this in terms of a square root of 10, so this dc over dt is going to simplify to the following: 7.91 meters per second. So that is the rate at which the distance between this balloon and this bicyclist is increasing as the bicyclist goes this way and the balloon goes this way. So here's a humongously complicated related rates problem. If you have any questions on anything in this video, let me know.